The term polarization, it means when we convert the transverse wave, it cannot be done for longitudinal. When we convert the transverse wave into only one component, we call that as a polarized light, and this process is called a polarization. So simple meaning of the term polarization means, first thing, like, you should understand the difference between polarized and unpolarized light, and then the process of this conversion to unpolarized to polarized light, this is called polarization. So in unpolarized electromagnetic radiation or unpolarized light, that occur or vibrate in all the direction and they are perpendicular to direction of propagation. Like a light can be conversion of unpolarized light to polarized light, that is called polarization. But what is the meaning or what is the definition of unpolarized light? The simple definition of unpolarized light means these are oscillations or vibration in all direction that are perpendicular to direction of propagation. So oscillation in all the direction and which are perpendicular to direction of propagation, we call that light as unpolarized light. Like example, if you have a metal, say a filament is there made up of tungsten. So we have this tungsten filament. Now what happens when you pass the current, when the charges are moving, it become hot, so means it produce heat and it produce light. It produce magnetic field as well, but it produce heat and light both. When it produce heat and light, if we check it in a microscopic level, like if I say this was a tungsten metal and these are the particles, the positive ion or the lattice. So what happened, they're not all vibrating in one plane, they're vibrating in different planes. These ions in the lattice, they will vibrate in different planes. So when they will vibrate in different planes, they will give rise to different waves in different direction, like different vibration. Some of them like maybe exactly vertical, some of them horizontal, some of them making certain angle diagonals. So this light in which is produced by vibration of the particle in different planes, different modes, this light or this radiation is called unpolarized light. But looking at this light, like example, when you're looking at the light which is coming out from the filament, you don't see vibration in a horizontal plane or vertical plane. You see as a light because you're not able to detect the light waves as they are having the very high speed and the frequency. But your this light is will be bright because it will have more vibrations, more plane of vibration, and the direction of this, the direction in which they are traveling, that is perpendicular to the vibration of all this. So example, if this wave is traveling, you can see all are 90-degree, all vibration are 90-degree to the direction of the travel or direction of propagation. So this light is called unpolarized light, light which is having multiple vibrations and oscillation in all the direction which are perpendicular to direction of propagation. But what is polarized light? Light which is having a single direction that is perpendicular to propagation. So it is oscillation in one direction which is perpendicular to direction of propagation, and that light is called polarized light. So example of polarized light, like example, you can convert a polarized light, unpolarized light into polarized light. So as you can see, it can be any plane, any vibration, but only one component is there, and the wave, the direction of propagation is 90 degree to the direction of vibration of the plane. That light, the red one is representing the vibrations, oscillation, and the black line is representing a propagation. And this light which is having only one plane, that is called a polarized light. But what will be the difference while looking at the naked eye? What you will observe, the only difference what you will see is that unpolarized light will have a higher intensity, because you can see more energy is entering in the wave, or more energy is there, or more waves are there which have a makes a high intensity. And unpolarized light, when you are observing, it will be dim. And when we convert the unpolarized light into polarized light, this effect, this method is known as polarization. So what happened, like example, if we have unpolarized light which is having many direction, like direction of vibration are there, and which are perpendicular or 90 degree to the propagation. And what we did, we passed this through a polarizing filter. This is a polarizing filter. So when we pass this through a polarizing filter, this polarizing filter absorb example all and only allow one component of a light to pass through. When it allow only one component of a light to pass through, either it can be vertical, horizontal, or any plane. Example, it allowed the vertical one. So this change to from unpolarized light to the polarized light through, when we use a polarizing filter or polarizer, we call this effect as polarization. So polarizing filters, different types of materials have a polarizing capability. Some of the materials have tendency to rotate the polarized light. Some of the materials have tendency to just absorb all the plane and only allow, like the component which is parallel to the plane, they allow that. So example, if the first polarizing filter, when I place this first polarizing filter, it was having a vertical plane. Then in front of this, I place another polarizing filter which is having a horizontal plane. What I will observe here, any light or no light? What we will observe? Is there any light will able to pass through, or no light will be there? So there is no light, because what happened, the horizontal polarizing filter here means it can only allow the horizontal component to pass, it does not allow vertical to pass. And vertical polarizing filter means it can only allow vertical to pass, and horizontal it does not allow it to pass. So when two polarizing filters are 90-degree angle difference, then we will not observe any light. So if two polarizing filters initially are the same, the angle difference is 0, then one is horizontal, then vertical back again. Example, these are two same type of polarizing filters, but we rotated 90, and again that's rotation 180. So this was 0 angle rotation, then it is 90 angle rotation, then it is 180, like we completely flipped it, and then from 180 again if I flip, this will become 270, and from 270 if I return back, this will be 360. Now first we have an unpolarized light. So when we pass this through a polarizing filter, only the vertical component is able to pass through the first polarizing filter. Then we did not rotate, so it will allow. But when it is 90-degree, there will be no light. Then again it is 180, it will allow. If it is 270, there is no light. And then again 360, it will allow. So it depends on the plane of the two polarizing filters. If they are same, then they will allow. If it is 90-degree, does not allow, or 180 again allow, 270 does not allow. Is it clear? This part, the rotation of the polarizing filter, which result in light and no light. Then simple where you can observe this polarizing effect, like example, say this is a water surface. Okay, the water is clear water, and you're looking from here at this site in a daytime when the sun is shining. The light which is coming out from the sun is unpolarized light. It is having many planes of vibration. When this light strike the water and bounce back from the water surface, reflected back from the water surface, not all, but there's a part. So this light become partially polarized, partially horizontal polarized. Means horizontal component is there and there's other component, but partially horizontal polarized. And because for light, refraction can also happen. So the light, some of the light will refract, enter the water surface, and under the water, example, the underwater, you're able to see the objects, things which are under the water because of refraction of the light. So when this light is refracted and enter our eye, this light is vertically polarized, because due to refraction and reflection, the light can also be, using a polarizing filter, we can like make unpolarized to polarized light, or by reflection and refraction it can also be done. So what happened? You're receiving the horizontal component and you're receiving the vertical component. That's why when you are looking at this water surface, you will see the reflection. You will see the reflection as well, and you will see a refraction, like what is underwater, the things which are underwater, that you will also see, but that will not be clear. It will be a glare, like a reflection and a refraction happening at the same time. So it will not be a clear image, clear vision for you. Now what you can do for this purpose, what are sunglasses? Actually, the sunglasses are the polarizing filters. So if another person is there who's having these sunglasses, and these are the polarizing filter, so what happened, the sunglasses allow only one component to pass and other it will block, and when it will allow one to pass and other it will block. So you will see clearly what is under water, because you are not receiving the second component, which is due to reflection and which is partially horizontal polarized. That is why, like when you are using a sunglasses, the surrounding appear to be dim. Why the surrounding appear to be dim? Because these polarizing filters of the sunglasses, they are only allowing one component. Like there are many component of vibration, and the sunglasses are only allowing one component to pass. That is why when you will see an object through the sunglasses, it will appear to be dim at daytime. Is it clear? The effect, the polarization, the concept. So you will be able to receive what is underwater, but not due to the reflection. Any doubt in this? There are more examples related to polarization that we will discuss in the topic wise discussion questions. Is it clear to everyone? Then we have a pulse echo method. What we do in this pulse echo method, this is simple concept, like it can be used to find the detail of the image, or it can be used to find the distance between the source and the observer. Like here is an object and I have a source, like example, it can be a sound source, it can be a light source, radio wave, any kind of wave. So when we send the wave will travel and it will bounce back. So the formula is, because it's a reflection, so its speed is 2d divided by t. If I know the speed of the speed of the wave, if I'm using a sound wave, then it will be 330. If I'm using electromagnetic radiation, then it will be 3 exponented. So speed multiplied by time divided by 2, that will give us the distance. What is the time? The time for the pulse to travel and return back. Speed is known, divide by 2. So I will know the distance between the source and the object. Why we call that as a pulse? Because we are not sending a continuous wave. Why we are not sending a continuous wave? In the first session we discussed, because when the waves strike, the two waves which are traveling in opposite direction, they may interfere and give rise to a standing wave. So we don't want to produce a standing wave, because maybe near the source, if it is producing a node, so they might cancel out each other. So as they might cancel out each other, we will not be able to detect any radiation. That's why we use a small signal or a pulse, means one wavelength or less than one wavelength is pulse. So one we will send, and one it strike, we will receive that, and then we will send another pulse or another signal. So reason for using a pulse, so that it will not produce a standing wave, and one pulse can be sent and received at the same time. And to get the detail image, like example, the term detail image means how many points the pulse reflected within the object. That is called a detail of image. Like this is an object and we are using a pulse which is having a length of 2 centimeter. So when this pulse will hit the object, it will bounce back. That is one thing, but not all of it will bounce back. A small part of the pulse will bounce back. Then it will complete its one vibration, full vibration, or what is the length of the pulse. And then again the part of the pulse will bounce back. Then it will continue its vibration. Once it completes its vibration, the length of the pulse, again what happened? The part of the pulse will bounce back. Then it will continue its vibration. Then the part of the pulse will bounce back. Further continue its vibration. The part of the pulse will bounce back. And then it will bounce back from the end as well. So how many points we are getting? We are getting 1, 2, 3, 4, and there will be a fifth one as well, which I did not draw. Like example, there will be fifth one, and then when it complete, it will also bounce back. So within the object, we are getting 5 points. So we are getting a detail image of 5 vibrations. Same thing, if we want to increase the detail, what we should do, we should decrease the wavelength, because when I use a shorter wavelength of a pulse of shorter wavelength will give us more points with inside the object as compared to a pulse of longer wavelength. So when we use a pulse, we prefer a shorter wavelength for more detailed image. But the limitation is that we cannot use this for too small wavelength, because if the too small wavelength is there, maybe wavelength will be absorbed by the material or object, or it might not reflect back. Is it clear, the concept of the pulse echo method technique? So in ultrasound, normally this technique of pulse echo method or pulse echo technique is used in ultrasound when they send the radiation and it bounce back. So using this technique, can identify the size of the organ. Is it clear to everyone? So this is it for the class today. Today we discussed the standing wave, the polarization, standing waves, the Doppler effect, polarization, and the pulse echo method. Next session we will do the past paper question related to waves. So waves, we are done with waves topic. The last topic will be about light, and then we'll finish unit 2 as well. But we'll do at least for 2 or 3 sessions, we will do questions from the topic wave, because this is an important topic. So when you will solve question, you will have a better understanding of these topics as well. Any question related to the class today?